So let's say that we have a round table, and we have 3 chairs around that round table. So this is one chair right over here, this is another chair, and that is another chair. And we can number the chairs. That is chair 1, that is chair 2, and that is chair 3. And let's assume that there are 3 people who want to sit in these 3 chairs. So there is person A, there is person B, and there is person C. And what we want to do is we want to count the number of ways that these 3 people could sit in these 3 chairs. And what do I mean by that? Well, if A sits in chair 1, B sits in chair 3, and C sits in chair 2, that is one scenario right over there. So this is one of the possible scenarios, A in seat 1, C in seat 2, B in seat 3. Another scenario could be B in seat 1, B in seat 1. Maybe C still sits in seat 2, C still sits there, and now A would be in seat 3. So this is one scenario and 2 scenarios. So my question to you is, how many scenarios are there like this? And I encourage you to pause the video and try to think through it. So I'm assuming you've had a go at it. Now let's work through it together. And I want to do it very systematically so that we don't forget any of the scenarios. And the way I'm going to do it is I'm going to create 3 blanks that represent each of the chairs. So here it's in a circle, but we could just say, okay, that blank is chair 1, that's the blank for chair 2, and that is the blank for chair 3. And I'm going to start with seat 1, and I'm going to say, well, what are the different scenarios? A could sit there, B could sit there, C could sit there. And then for each of those, figure out who could sit in seat 2. And then for each of those, figure out who could sit in seat 3. So let's do that. So first, what are the scenarios of who could sit in seat 1? So actually, maybe I'll write it this way. So maybe I'll do seat 1. So right now, we're only going to fill seat 1. Well, A could sit in seat 1. In which case we don't know, or we haven't filled it seat 2 or seat 3 yet. So this 2 or 3. B could sit in seat 1, and we haven't figured out who sits in seat 2 or seat 3 yet. And then we could have C sitting in seat 1, and we still have to figure out who's going to sit in seat 2 and seat 3. Now, for each of these, let's figure out who could be sitting in seat 2. So seats 1 and 2. So for this one right over here, we could either have, so we have A in seat 1 for sure. Now we could either have B sitting in seat 2, in which case actually I'll leave this blank, although you could use a little bit of deductive reasoning to figure out who's going to be sitting in seat 3. So I'll leave seat 3 blank. Or you could have C sitting in seat 2. And now we still haven't figured out who's sitting in seat 3, although once again, a little bit of deductive reasoning might tell us. So these are the scenarios where A is in seat 1. Now what about when B is in seat 1? Well, we could put A in seat 2, and we still need to figure out who's in seat 3. Or we could put C in seat 2, and we still need to figure out who's going to be in seat 3. And then finally, let's look at C, where C is in seat 1. Well, you could either put A in seat 2, or you could put B in seat 2. All right, now let's fill out all 3 of the seats. So seats 1, 2, and 3. Well, for this scenario right over here, there's only one option that you could put in seat 3. The only person who hasn't sat down yet is person C. So this will be A, B, C. And what would this one be? Well, the only person who hasn't sat down in this scenario yet to fill this chair, the only option for this chair, there's only one option here. It's going to be person B. So it's A, C, B. This one is going to be B, A, C. C is the only person who could sit there. A is the only person who could sit there. B, C, A. And then here, B is the only person who could sit in seat 3. And here, A is the only person who could sit in seat 3. So how many scenarios do we have? We have 1, 2, 3, 4, 5, and 6. And 6 is our answer. That's the number of scenarios that you could have the different people sitting in the different chairs. Now, I know what you're thinking. Okay, Sal, this was a scenario with 3 people and 3 chairs. And, I might have been able to just do this even if I didn't do it systematically. But, what if things get a lot more, if I have many, many more chairs? What if I had 60 chairs? Well, the number of scenarios would get fairly large. What if I had 5 people and 5 chairs. Even this method right over here would take up a lot of paper space or a lot of screen space. What do we do in that scenario? And the realization here is just thinking about what happened here. We said, look, how many people could sit in seat 1? So when we were filling, if we're going seat by seat, how many possibilities were there to put in seat 1? Well, if you're seating in order, if you haven't filled any of the seats yet, right at the beginning, well, there's 3 possible people who could sit in seat 1. You see it right over here. 1, 2, 3, because there's 3 possible people. Now, how many people, for each of those, how many people could sit in seat 2? Well, for each of them, let's say the scenario where A is sitting in seat 1, there was 2 possibilities for who could sit in seat 2. Notice, let me do this in a different color. So this right over here. For each of these 3, there's 2 possibilities of who could sit in seat 2. If A is sitting in seat 1, you could have either B or C in seat 2. If B is sitting in seat 1, you have either A or C for seat 2. So for each of these 3, you have 2 possibilities of who could sit in seat 2. And so for each of these, so you have 6 possibilities where you're filling in 3 times 2, or you're filling in how many the scenarios for seats 1 and 2. And then for each of those, how many scenarios are who could sit in the last seat, in seat 3? Well, for each of those, there was only one possibility for who could sit in seat 3. We see it right there, and that's because there's only one person left who hasn't sat down yet. So how many total possibilities are there? Well, 3 times 2 times 1 is equal to 6. And so if we were to do that same exact thought exercise, would say 5 seats. Let's go through that exercise. It's interesting. So if we have 1, 2, 3, 4, 5. So this is 5 seats with 5 people sitting down. We want to figure out how many scenarios are there for all the different people in all the different seats. Well, for the first seat, there's 5 different people who could sit in it. Now, for each of those scenarios, there's 4 people who haven't sat down left yet who could sit in the second seat. Now, for each of those scenarios, there's going to be 3 people who haven't sat down yet. So those are the people who could sit in the third seat if we're filling out the seats in this order. Now, for each of all of these scenarios, there's 2 people left who haven't sat down yet who could sit in the fourth seat. And then for all of these scenarios, well, there's only one person left who hasn't sat down who would have to sit in the fifth seat. So if you had this exact same thing, but instead of 3 chairs, you had 5 chairs, the number of scenarios would be 5 times 4 times 3 times 2 times 1, which is what? 20 times 6, which is equal to 120 scenarios. And so you see that the scenarios grow fairly quickly. And if you're wondering, hey, this is kind of a neat mathematical thing, 3 times 2 times 1, or 5 times 4 times 3 times 2 times 1. Like if you start with a number and you multiply that number times the number 1 less than that times the number 1 less than that, all the way down to getting to 1, well, it seems like a neat kind of fun mathematical operation. And lucky for you, or maybe unlucky for you, because this might have been your chance at fame, this operation has already been defined. It's called the factorial. It's called the factorial operation. So this thing right over here, this is the same thing as 3 factorial. You write this little exclamation mark. This right over here, this is the same thing as 5 factorial. So if in general, if I said, let's say 6 factorial, that would be equal to 6 times 5 times 4 times 3 times 2 times 1. Anyway, hopefully you enjoyed that.